welcome back to another video. So in this video, our topic is using properties of operations to create equivalent expressions. So we have the same unit, which is expressions, and we have a different topic now. It is, we are going to use properties of operations to create equivalent expressions. So let's see what equivalent and expression actually means. So for equivalent, it means equal. So we are going to write equal expressions. And expressions means collection of symbols that express a quantity. So for expressions, we have different symbols collected together that jointly express a quantity. So we are going to use properties of operations to write equal collection of symbols that express the same quantity. So now, let's move on to our first question. So here we have our first question. It says, the student council has spent $300 on the supplies needed to sponsor a dance concert fundraiser. 3 council members wrote the following expressions to represent the total amount raised for tea tickets sold. Are all of them correct? Are they all correct? So let's look at the problem. So it says that they spent $300 on the supplies, and they wrote expressions to represent the total amount raised for the tickets sold. Now, for when it says they spent, right here it says the student council has spent. So that means it comes in a negative way. So the spent has a negative effect. Then we have how much they raised. So for raised, we need to show that it is addition sign here. So we know that out of all the amount they raised, they have to subtract the $300 that were spent to get the amount that they actually raised. And we have the tickets here. It says $6 for each ticket. So first, we are given the expressions here. We are given 3 expressions, and we need to see if all of them are the correct expressions. So let's see. So first, let's create an expression of our own. So we need to know how much they spent. They spent $300, so that is going to be subtract 300. And then we are going to add $6 times T, meaning that is the amount of that's the way we are going to know how much they raised from the tickets that people bought. So for that, it is going to be 6 times T. So first, we are going to multiply the 6 by the number of tickets sold. The 6T shows how much they earned. But in order to know how much they raised, they need to subtract $300 from it to know how much they raised. So this is the expression that we made, which is 6T subtract 300. So the first one is automatically correct. So we have the first one as correct. It is correct. Now let's look at the second one. It says 6, and then we have T subtract 15. So let's see if this is correct. We need to use the distributive property to solve this one. So if this ends up like this one or this one, meaning it is correct. So 6 times T times and 6 times negative 50. We're not going to multiply 6 by only 50. This is the whole number, negative 50. Such as negative 300 is the whole number here. So it's the entire number. So now we're going to multiply 6 times T plus 6 times negative 50. So if we do that, we will get 6T plus 6 times negative 50 will give us negative 300 here. Now we have these 2 signs, and if we have a plus and subtraction, it will definitely turn into, or automatically turn into, a negative sign. So we have 60 subtract 300. And yes, this one is also correct since it ends up the same way as this one. So the second one is also correct. Now we have the third one here, which is negative 300 plus 60. So now here, we need to see if this is also the same as this. The way we can do it, we can arrange these numbers, or we can change the place for this number. So negative 300 plus 60, or we can put plus 60 first and then negative 300. Be sure that you put plus 60, that's the whole number, and negative 300. You cannot only put only 300 or 300 plus. This goes with this number and this sign goes with this number. So let's put this first. So plus 60. And then we have subtract 300. So subtract 300. And we don't really need to put a plus in front of numbers that we don't have here. So if we don't have a plus, it definitely means it is a positive number. So yes, this also ends up the same as this one. So this is also the correct expression. Another way we can do these expressions is by substituting or by evaluating. Let's say t equals 70. So we have t equals 70, meaning 6 times 70 subtract 300. So when we do that, 6 times 70 is going to give us 420. Subtract 300, which will give us 120. So this is how much they raised if there were 70 tickets sold. And we can try the same with each of these expressions. So let me just quickly erase this. So let's substitute t for 70 here too. So 6 times t, so the t will become 70 here. So 6 times 70 is going to give us 420. 6 times negative 50 will give us subtract or negative 300, which will also end up in $120. Let's do the same here. So negative 300. We're going to erase this real quick. So negative 300 plus 6 times 70. So if we do that, negative 300 plus 420, we will also end up with $120. For all of these expressions, if we evaluate the t for the same number, we will get the same answer, which means that all of these expressions are equivalent. So now let's move on to our second question. So here we have our second question. It says, Nancy wrote the expression 3x subtract 12 to represent the relationship in a table of values. Use properties of operations to write two equivalent expressions. So now here we are given one expression and we are supposed to create two equivalent expressions, meaning two expressions that are the same or that give the same answer as the expression that we are given, 3x subtract 12. So let's first write the expression that we are given. 3x subtract 12. So as we did last time, this is going to be our first expression. So we're going to make two expressions based on this. So let's see what we can do. We can distribute this to make a new expression, which is equivalent, just like we did last time. So we have 3x subtract 12. And the way we did last time, the format is we have a here, we have x here, and then we have a number here, which is, let's say, question mark. So this is what we have. We are going to have a subtraction sign here so that it will give us negative something here. So now let's try to fit the values in. So we need to multiply this number by this to get 3x, and then this same number to multiply by this number and get negative 12. So if we multiply 3 by x, we will get 3x. And if we multiply, now we have to multiply this by this number, so subtract. What do we multiply 3 by to get 12? We get 4, so 3 times 4 is 12. 3 times negative 4 is negative 12. So this is our new expression. So let's see what it ends up with. 3x subtract 3 times negative 4 is negative 12. So negative 12. And yes, this ends up the same expression. So now let's do another one, the third one. So here we can just rearrange the order of numbers. So we have 3x subtract 12. Let's take this one. We have two collection of symbols for numbers here. So first we have the negative 12, and then another one we have is 3x. So we can rearrange it. First we have it in one order already, it is 3x subtract 12. Another order can be made as 12, negative 12. Now remember that 3x is actually plus 3x. Just because plus is not written, it does not mean that it is negative or another operation. If the plus is not written there, it means that it is a positive number. So plus 3x. So that is going to be our third expression. We can now, as I did before in the last one, we can evaluate these x's to make sure that we actually got the right answer. So first, let's rewrite the second expression. It was 3 times x subtract 4 in the bracket. So now, let's say x equals 6. So 3 times 6 subtract 12 is 6 times 3 is 18. Subtract 12 will give us 6. So that's our answer. Now we should get 6 for this and 6 for this, and we should evaluate the x for 6 here. So 3 and 6 subtract 4 here. So 3 times 6 subtract 4 is 2, and 3 times 2 is 6. So we got the same answer for this. Negative 12 plus 3 times 6. So negative 12 plus 18. If we do that, we will still get 6. So here, if we can see that all of these expressions end up in the same answer when x is evaluated for a number. So that means all of these expressions are equivalent. So that's it for today's video. If you guys like this video, please give this video a thumbs up, and don't forget to subscribe to our channel and ring the notification bell so you get the notification every time our new video comes out.